Okay, classwork, day 6, unit 3. We're going to work on the identities on the back. So, we only want to work with one side. We want to work with the more complicated side. And we always want to be thinking through of what's going to help us. These are kind of our 4 things. Am I adding or subtracting fractions? Should I be finding a common denominator? Can I factor either a GCF? Is it a quadratic? Is it difference of squares? Is it Pythagorean identities? Something squared or something squared with a 1? Or will changing everything to sine and cosine help? So that's kind of the 4 strategies if you get stuck to help us through. So this first one I can immediately see is fractions. And I'm adding, and I could do a common denominator, but what I'm also noticing here is I think it might be helpful to change everything in terms of cosine and sine. So I'm going to turn cosecant into 1 over sine, which means that the sine is going to be on the bottom, and I'm going to turn secant into 1 over cosine, which means cosine is going to be on the top. And again, the reason I saw that is I'm looking at what this is, and I'm noticing that cosecant is the reciprocal of sine, and sine's on the bottom here, and secant is the reciprocal of cosine. So some of your decisions are on those 4 things, but some of it is based on your problem. And so for this problem, instead of finding a common denominator, because I recognize this, I'm just changing these. So now what I have is I have 2 fractions added with a common denominator. The common denominator is sine. So I have, I could either add them and get 2 cosine over sine, or notice what I have here, I have cotangent. So it'll work out both ways, but I can see right away that that is cotangent, right? Cosine over sine is cotangent, and that is cotangent. And I have 1 cotangent plus 1 cotangent is 2 cotangent, which is what I wanted to get. Okay, number 11. So number 11 is 2 fractions. So again, on this one, yes, I could find the common denominator, but here's why I'm not. I'm recognizing that this is a Pythagorean identity on the top, and when I have this Pythagorean identity, I get difference of squares. And this is a factor of difference of squares. So that's why I'm doing what I'm doing. So a lot of it is just looking at the problem and making decisions based on your problem. So this fraction becomes 1 minus cosine squared theta over 1 minus cosine theta. And we just said that this is difference of squares. So 1 minus 1 plus cosine theta, 1 minus cosine theta, over 1 minus cosine theta. So now I have the 1 minus cosine theta canceling with 1 minus cosine theta, and I'm left with this. Now make sure you distribute the negative to both. It's 1 minus 1 minus cosine theta. So the 1's are gone. 1 minus 1 is 0, and I'm just left with negative cosine theta, which is what I wanted. All right, number 12. This one is an identity we haven't worked with much, but it's on your sheet. It's the even and odd identities. It tells us that cotangent of a negative angle is the same thing as negative cotangent of that angle. So right away, I'm just going to replace this with negative cotangent of theta. And again, that comes right from your sheet. And then on the bottom, I have cosecant. I'm trying to get cosine, so that's a big hint that perhaps changing things to sine and cosine is going to help me. So negative cotangent would be negative cosine theta over sine theta, and this is divided by 1 over sine theta. And of course, when you divide fractions, I'm going to go up here, you keep the first, change it to multiplication, and flip the second. So now I can see that my sines are going to cancel, and I am left with negative cosine theta, which is what I wanted. All right, number 13. I'm trying to end up in cosecant. I'm adding, but they're not fractions, not yet at least. So this is one, it's not Pythagorean identities. Right now I can't do a common denominator. There's no factoring. So I'm going to change everything to sine and cosine. So I have sine theta plus cosine theta, and cotangent is cosine theta over sine theta. So now on the top I have sine theta plus cosine squared theta over sine. Now I have two fractions added. I'm going to get a common denominator. The common denominator is sine theta. So this one's fine. I don't have to multiply anything here, but this one needs to be multiplied by sine theta. So that gives me sine squared theta plus cosine squared theta over sine theta. So again, right away you should recognize that this equals 1. So I have 1 over sine theta, which is the same thing as cosecant theta, which is what I wanted to have. Number 14. So again, right now, I don't have really a lot of options. I already have everything in cosine and sine. I'm not adding or subtracting fractions. I don't have anything squared. I don't have any factoring. So this is one where you kind of got to think, okay, all those four options are not working for me right now. What can I do? Well, you can always multiply a fraction by the same thing on the top and bottom without it changing, right? 1/2, if I multiply top and bottom, by 2 gives me 2/4, and those are equivalent fractions. So I can see that this is a factor of difference of squares. I'm going to multiply top and bottom by 1 plus sine theta, because then I'm going to have some more options to deal with. And again, difference of squares means I have 1 minus sine squared on the bottom. So I multiply top and bottom times 1 plus sine theta. All right, so on the top now, again, I don't want to distribute because it is easier to cancel things when they are multiplied than distributed. Right now, if I have a cosine on the bottom, I will be able to cancel. If I have a 1 plus sine on the bottom, I can cancel. Of course, I don't want to do that because I can see back here. So what I'm going to do is leave the top alone, and I'm going to turn the bottom into cosine squared. It's a Pythagorean identity. And now I can cancel this cosine with one of those, which gives me, let's try to get this clear, which gives me 1 plus sine theta over cosine theta. It's not right where I want to be yet, but take a look at how this works, right? When I divide, if I have only one thing on the bottom, this is saying this is 1 over cosine theta plus sine theta over cosine theta. I can split it up. So again, this equals 1 over cosine theta plus sine theta over cosine theta. This is basically the before I add, right? This is my common denominator. And if I added these two fractions, that's my common denominator, which is here, and that would be my top, 1 plus sine theta. But I know that 1 over cosine theta is secant theta, and I know that sine theta over cosine theta is tangent theta, which is what I wanted it to equal. All right. So this one, kind of similar to number 10 that we did. Yes, I have some fractions. So yes, I might want to think about a common denominator. And everything's already in, well, not everything, but I might want to think about a common denominator. But take a look at what I have, the actual problem. I have sine divided by its reciprocal. That means that what I have is sine times sine. So that on the top of this problem gives me sine squared. And what I have here is cosine divided by its reciprocal, which is cosine times cosine. Well, sine squared plus cosine squared is 1, and I get 1, and that's what I wanted. So again, sometimes you really just have to look at the problem and see what you have before you just start blindly trying some of the steps. Make sure you're actually looking to see what might help you, because it may not be the exact thing. Like I said, this one I didn't find a common denominator, and that's because I recognized that I had a function divided by its reciprocal. All right, last one here, 16. So this one I definitely have two fractions added. Everything's already in sine and cosine. I need a common denominator. So this one is missing the 1 plus cosine theta. This is missing the sine theta. So this fraction, I'm multiplying by 1 plus cosine theta, which is 1 plus cosine theta squared. So again, that's the first term squared, the middle two multiplied, so cosine theta times 1, multiplied together, but you have two of them. So 2 cosine theta, and then the last term squared, cosine squared theta. This one is missing sine, which gives me sine squared theta, all over sine theta times 1 plus cosine theta. Again, we're keeping it. We're not distributing. It's easier to cancel when things are multiplied. Right away I noticed that cosine squared and sine squared is 1. So now I have on the top 2 plus 2 cosine theta over sine theta, 1 plus cosine theta. These both have a 2 in common, so I can factor out a 2. That gives me 2 times 1 plus cosine theta over sine theta, 1 plus cosine theta, and 1 plus cosine theta and 1 plus cosine theta cancels, which gives me 2 over sine theta, which is 2 cosecant theta, which is what I wanted.